And I'm Becca.
And tonight we'll be talking about microplastics in our salt marshes.
Okay, so here displayed we have a picture of a salt marsh. And what a salt marsh is it's a habitat in between an ocean and rivers. And it's basically a buffer in between those two habitats in a way. And when we were looking for information on microplastics in salt marshes, we didn't really find anything. So this was totally new, and we were going into it not really knowing much about what we were going to find.
So salt marshes provide us humans many benefits, as well as pretty much like all of the coast of Maine. They take in storm energy, so when a storm's coming, they are like a sponge and just suck in a lot of that storm energy, protecting our coastline.
Salt marshes are also a nursery for commercial fish. And so a lot of the fish in our ocean today have probably grown up in a salt marsh at one point because it is a safer environment than the actual ocean is.
Salt marshes are also a natural filtration system, and they absorb pollutants. An increasing pollutant that we see in today is microplastics, and so we want to base our study off of microplastics.
So mass production of microplastics began in the 1940s.
Actually, over 300 million tons will have been produced from 1940 to 2015.
And only 6.5 of plastics actually get recycled each year, and they take such a long time to biodegrade, about 450 to 1,000 years. Microplastics come from a lot of different things. They come from face washes and cosmetics. They come from your clothing and a lot of deteriorating plastic objects.
So the first question that we had was, where are microplastics coming from? So either they're coming from rivers and fresh water flowing into the salt marshes, or they're coming from the ocean. We hypothesized that they were coming from rivers.
The next question we had was if we would see a change in abundance of microplastics over time. So peat, which is the soil of a salt marsh or the earth, it takes a really long time to accumulate. There's about 1 millimeter per year. So we hypothesized that we would see less microplastics at the bottom of our sample rather than the top, because the top is going to be newer and fresh.
And we also wondered, is there a difference in abundance of microplastics found in protected versus unprotected salt marshes? So we hypothesized that there would be less microplastics in protected salt marshes compared to unprotected salt marshes, because those that are protected are farther away from human production. So the first thing that we did is we took sediment cores with this PVC pipe about this long, and we stuck it into the ground and took it up, and we got these beautiful sediment cores. Beautiful.
We also fell in the mud quite a bit because a salt marsh is really hard to walk in and the mud's really dense and thick.
And to filter our sediment samples, we use something called filter paper. And to count our microplastics, we use something called a dissecting scope.
So we sampled at 2 conserved sites. So at Popham Beach, at the up marsh here, and then at the down marsh. And then we sampled at Scarborough, at up and down marsh. So the down marsh, as you can see, is coming from in from the ocean, and then the up marsh is coming. The up marsh has water coming in from streams and rivers.
We also sampled at one unprotected salt marsh, which was on Adams Road in Brunswick, Maine. And again, like Cam said, the up marsh is where rivers and streams are coming from, and the down marsh is where it meets the ocean.
So this graph here shows us where microplastics are coming from. As you can see, Scarborough here has a significant amount of microplastics. And the pink is for the upmarsh samples, and the teal is for downmarsh samples.
Also, well, going back and looking at maps of Scarborough, we saw that the river that was leading into Scarborough was actually coming straight from Portland, which is a really high, dense, populated area and industrial area.
And for Adams Road, we also saw a lot of microplastics. For downmarsh samples, we found a lot at Popham, but for the most microplastics for downmarsh, we found the most on Adams Road.
So so here we show how microplastics are varying over time. So the pink is the top sample or the top layer of the salt marsh. So that is the sediment coming from more recent years because it takes about a year for 1 millimeter to accumulate. And then as it gets towards the bottom layer, it goes further back in time when microplastics weren't quite introduced as much.
This next graph is showing us the difference between the microplastics found in a protected salt marsh and an unprotected salt marsh. And if you look at the graph, you'll see that Adams Road has a significant number of microplastics, which was our unprotected salt marsh. However, we do see a great number of microplastics in our 2 protected sites as well.
So for where microplastics are coming from, we hypothesize that they're coming from rivers. But we can't always tell how many microplastics are going to be for each salt marsh, because it depends on where the salt marsh is located. If a salt marsh is located in a heavily populated area, more microplastics might flow down through the rivers.
This also means that there's going to be a diverse amount of sources from the microplastics, so there's no way of really determining it.
So because of the recent introduction of microplastics into our salt marshes, the salt marshes are providing a new ecosystem service, and they have just, because they are starting to absorb microplastics, we do not know how this is going to affect organisms living in the salt marsh.
For our next question, we hypothesized that there was going to be a greater number of microplastics in an unprotected salt marsh. So maybe conservation will play a role in this because in our unprotected salt marsh we did find more microplastics. However, we did find a lot of microplastics in our protected salt marshes, so there's no real way of determining it. So I want to thank you so much for your time.
Thank you. Shout out to Rachel and Carrie for everything that you did for us, for driving us around and helping us count microplastics and just everything that you do. Thank you.
All right. Any questions, please? Yes.
Yeah, I was wondering if you did any actual statistical analysis to see if the differences, say, in protected or unprotected or top layer versus bottom layer, those differences were significant themselves.
I don't think we did that, but well, we want to do that. That's
Were you able to figure out, knowing how quickly marshes accrete, could you figure out kind of a time frame for your sample?
So our top sample was 4 inches for the top, so it's about an inch every 10 years, so that's about 40 years old. And our bottom sample was another 4 inches, so that's going to be an 80-year.
Any other questions? Thank you so much.